Here are solutions to the worksheet from section 1.2 that we worked on at the beginning of class on Wednesday. The first problem is to write the different descriptions of spans of values of x using interval notation. So, and number two is to do the same thing with the number lines. So some people prefer doing one or the other first. For us, it's important to be able to understand both of them. So what I'm going to do is do number two first. I'm going to shade the number lines first, and then I'm going to write the interval notation from that. So part A is asking us for values between 2 and 5, and that's exactly the same thing we did in class, but now we're saying or values greater than 7. So we're adding to the problem that we did in class. So 2 to 5 would be here to here, so everything between 2 and 5, and then 7 plus greater than 7 will be out this direction. The less than sign here is telling me not to include the 2. The less than or equal to symbol is telling me that I should include 5 as a possibility. And the other part here, x greater than 7, there's not an equal to here, just greater than 7, meaning I don't want to include 7. And the first inequality is telling me to shade between 2 and 5. And the second one is telling me to shade from 7 forever. So as long as I don't put a dot on the right-hand side, we assume they mean go on forever. So that's what the number line looks like. And what I normally think of is that the interval notation is shorthand for this. So I would write 2 comma 5 with a square bracket on the 5. Union, it's a bad U, union, and then 7 to infinity, that's an open interval for 7, not including, and then infinity, and we always use a rounded bracket around infinity. So that would be my answer to 1A using interval notation. All right, so part B, we're going to do numbers between -1 and 3, and we can see there that for the description in part B, we want to include the -1 because this is less than or equal to, and this is less than or equal to, meaning we include 3. And then this is telling us to shade everything in between. And so with interval notation, that would be square bracket, -1, 3 with a square bracket. And then finally, letter C is that, of course, that is the answer to B. This is the weird one that we talked about, where we're really describing everything except the number 1. I'm saying include everything less than 1 and everything bigger than 1. So that means 1's the only number that's not being included. So this would be everything less than 1. And then everything bigger than 1 would be like this. So the easiest way to say that is all numbers but 1. But if we have to use interval notation, we would write it like this with rounded brackets, union, 1 to infinity. So everything is a rounded bracket because we're not including the 1, a rounded paren. The problems 3 and 4 are asking us for the domain of the function, and we talked about in class that the domain is just the set of legal values that you can put in. In other words, the values that you can put into the function where your calculator will not give you an error. And so the number 3 here involves a fraction, and we know that the only time a fraction calculation in the calculator is going to give me an error is if the denominator is 0. So we did this in 2 steps. We said, let's figure out which x make the denominator 0. So whatever the denominator is, my first step is figure out where that is equal to 0. And so that happens when x equals 8. So my answer is all numbers except 8 are acceptable. So that would be my answer to the domain question. And if I had to write that using interval notation, I would do that using a convention like we did for part C up here, where I would say everything less than 8 or everything bigger than 8. And that would that would be an interval way of saying that same thing. Number 4 is has a square root symbol, and so we said that the square root symbol on our calculator only gives us error messages if we try to take square roots of negative numbers. So we figure this out in 2 stages. We know that under the square root sign, we don't want to have a negative number. And so we figure this out by first figuring out where the stuff under the square root sign, I'm just focused on what the entire expression is under the square root sign. I'm first going to figure out where that's equal to 0. The reason I do that is because 0 is the break-even point, well, not break-even point, it's the transition point between negative numbers and positive numbers. And we know that negative numbers under the square root sign are bad, and positive numbers under the square root sign are okay. So the breaking point is going to be at 10x, whenever 10x minus 7 equals 0. So I have an algebra problem to do here to figure this out. I would add 10 to both sides and then divide both sides by 10. So my answer to that question would be x is 7/10. I'm going to give myself a number line here just to visualize. I'm going to put it down here where I haven't written yet so I can just get rid of it easily. But here's a number line. Here's 0. Here's 1. Here's 2. -1, -2. So 7/10 is about here. And notice that 7/10 is actually a fine value for x, for this function. It's fine if you put 7/10 in for x. We know that that makes this yellow part equal to 0. And then in your calculator, if you do 4 times the square root of 0 plus 3, you just get 3. There's no error message. So 7/10 should be included in my answer for the domain. 7/10 is a perfectly good value. But on one side or the other of 7/10, there's going to be a problem. So let's try, let's test on both sides of 7/10. So I'm going to test f of 0, see if I get an error message, and I'm going to test f of 1. I'm picking those 2 values just because they're on either side of this value. I know this is the critical value, and so on one side I expect I'm going to get error messages. On the other side I'm not. So let's give it a try. F of 0 is going to say 4 times the square root, and then putting 0 in for x is going to make this yellow stuff here be 10 times 0 minus 7, which is -7. So if I try to put 0 in for x, the calculation on the computation on my calculator is going to be 4 times the square root of -7 plus 3, and that's bad. So that's my lightning bolt. So so over on this side, that's bad. If I calculate f of 1 on the other hand, then in my calculator I'd be putting 4 times the square root, and again look at the yellow circled stuff. When x is 1, this is 10 times 1 minus 7, which is 3. So 4 times the square root of 3 plus 3. And I don't know what that is offhand. Square root of 3 is not a nice number, but I do know that my calculator is not going to give me an error message. And so on this side of that critical value, I'm happy. So what that means is that my shading should be in this direction. So I'm including the value 7/10, and I'm happy to shade in the right direction. And if I wanted to write that as an interval, I would use a closed bracket, because I have a solid dot there, 7/10, comma, infinity. So that would be the domain using interval notation. All right, so let me move this so I can write the next problem. For the last problem, this is a piecewise defined function, and right now all we're trying to do is be able to read the notation correctly and maybe plot some points from it. That's all that you'll see in section 1.2. But remember, when I evaluate, I have 2 steps to do. I have to first decide which piece this value refers to, and then I have to evaluate that piece. So use a value of -1 for x. Notice that -1 is less than 0, and so this piece is the one I need to use. So if the x is -1, I need to use the first piece. So my first step is figure out which piece I'm using, and my second step is then to plug the number. If I can get my pen to work. The second step is just plug the number, the -1, in for x in that piece. So we first determine that we want to use the first piece because -1 is less than 0. And then we go here and we plug -1 in for x. So that'll be 7 times -1 minus 10, which is -17. So f of -1 is -17. Let's do f of 2. For f of 2, again, I'm taking my value of x and I'm looking here to see which piece I should use. The number x should only make one of these statements true. 2 is not less than 0. 2 is greater than or equal to 0. So the second statement, the second piece, is the one at play for the x value of 2. And then my second step is just to plug 2 into the formula that's part of that second piece. So the formula for the second piece is 4x plus 2. So plugging 2 in for x, I would get 4 times 2 plus 2, which is 10. And then finally, f of 0, it falls right on the margins here, right? That's sort of the transition point between these two. But because I'm using greater than or equal to here, 0 would satisfy this condition. 0 is greater than or equal to 0. That's true. 0 is not less than 0. So it's the second piece, again, that's in play here. But I have to look at it a little more carefully to make that decision. So when the input is 0, I'm using the second piece of this piecewise defined function. And then the second piece's formula, just like before, is 4x plus 2. So putting 0 for x in the formula 4x plus 2 gives me 4 times 0 plus 2, which is 2. So if you want to do the next step with these, and you'll see this in some of the book problems, the online problems, is if we did want to plot these, I would be plotting the point -1, -17. Remember, when we plot the graph of a function, we're plotting input-output pairs. And it doesn't matter what the process is that we came to get those pairs, it's just input comma output. So we said when input's -1, output's -17. When input's 0, output is 2. When input's 2, output is 10. What you would expect to see when you plot this is this transition point, x equals 0, should play a key role. And on one side of x equals 0, the graph should look like this graph, which is a straight line with slope 7. And on the other side of 0, the graph should look like this, which is another line, but a line with slope 4. So that's what we should see when we start plotting these points, and we'll be following up with that in the next unit.